Hi guys, welcome back to the channel. This is a continuation of part 1 of the applications of ChatGPT in geospatial analysis tutorial. In the first part, we discussed in detail 3 examples of how ChatGPT can be used in aid of things like reading in shapefiles, visualizing geospatial data, and performing geospatial analysis. You can find the link to access that tutorial down in the description below, or alternatively, you can click on the link that's appearing on the top right corner of the screen as well. And in this video, we are going to discuss 3 more examples of how ChatGPT can be used as an aid to perform a few more geospatial operations. So without further ado, let's jump into example number 4. So in this example, we are going to ask ChatGPT to write a code snippet for the following case using GeoPandas library. Now there are 2 shapefiles. First shapefile is a polyline type shapefile which shows the extent of a river, and the second shapefile is a point shapefile showing locations of human settlements nearby the river. Now we are going to ask ChatGPT to write a code to import both shapefiles and plot the first and the second shapefiles on the same plot along with the settlements that lie within a buffer distance of 8 kilometers from the river. And we are also going to specify that we would like to see the buffer zone as a third shapefile on the same plot with an increased transparency so that we could see the settlements that lie within that boundary of the 8 kilometers buffer zone. And finally, we are asking it to include a line of code to calculate the number of settlements within that buffer zone as well. So now what I'm going to do is I'm going to specify that request right over here. Alright, now what we can do is just simply hit enter and see what sort of a response we are going to get from ChatGPT. Alright, now as you can see, it's basically making use of 2 different libraries, the GeoPandas as well as the Matplotlib library, to basically execute the tasks that we requested. And right over here you can see that it's basically reading in the 2 different shapefiles that we are going to provide. One is the shapefile of a river and the other one is the shapefile of the settlements. And over here it's basically assigning the buffer distance to a variable called buffer_distance, and after that it's using the buffer method to basically calculate the river buffer just like this. And right over here you can see that it's basically creating the figure and the axis object. And coming from the previous examples, now we are quite familiar with how we need to structure the lines of code if you want to plot multiple shapefiles on the same plot. So that's what's been done over here. And finally, it's using the within method to basically select the subset of settlements that lie within the buffer zone to basically calculate the number of settlements that lie within that buffer zone of 8 kilometers or 8,000 meters. Now what I'm going to do is I'm going to copy this code snippet and head back to my Jupyter notebook. And I'm going to create a new notebook for the example 4. And after that, simply going to paste the block of code that I copied from ChatGPT. And before we go ahead and execute this block of code, I think it's good to see what sort of shapefiles that we're actually dealing with. So what I'm going to do is I'm going to head back to my ArcMap project just to show you guys what kind of shapefiles that we're actually dealing with for this particular example. So as you can see over here, we have 2 shapefiles. The first one is a polyline object which basically shows the extent of a river. And the second shapefile is basically a point shapefile which shows the extent of different settlements around this river. So ideally what we are trying to do is we are trying to generate a buffer zone of 8,000 meters or 8 kilometers from the river and see which settlements are going to get sort of encompassed by the boundary of that 8,000 meters buffer zone. So now if you look at the actual shapefiles itself, this is how they look. So we have a river shapefile right over here. And we have the settlement shapefile right over here as well. So those are the 2 files that we will be importing into our project. So let's go ahead and set the file path to be river.shp. And I'm just simply going to copy this and paste it over here. And in this case, it should be settlements.shp. So that's going to take care of the process of reading in the two shapefiles. And during this process, it's going to create a buffer around the river, a buffer of 8 kilometers or 8,000 meters around the river. So what I'm going to do is I'm going to deactivate or comment out these 3 lines of code for the time being, and we'll try to run this block of code and see what sort of an output that we're supposed to get. Yeah, so right now you can see very clearly the extent of the river as well as the settlements in the form of points. And what's represented by this gray color buffer zone is basically the 8,000 kilometers buffer zone. Now, if you would like to make changes such as maybe increasing the marker size of the settlements, you can do that as well. Let's say instead of 5, if we go with 10. And for the color of the buffer zone, let's say if you would like to go with yellow color instead of gray, what we can do is we can make those changes and rerun the code. And you can see that the changes took place immediately. And similarly, because ChatGPT assigned this 8,000 meters buffer zone value to a separate variable, if you wanted to make changes to the buffer zone itself, all you have to do is just change this number right here. So let's say instead of 8,000 meters, if I'm interested in knowing the settlements within a buffer zone of 5,000 meters, so that's 5 kilometers, all I have to do is just change this number to 5,000. And if I rerun the code, you can see that my buffer zone kind of shrinked, and now the number of settlements within this 5,000 meters buffer zone might potentially be a bit lower than the number that we would have gotten if we were to use a buffer zone of 8,000 meters. So I think what we can do is we can just go ahead with 5,000 instead of 8,000. Wouldn't really matter in this case. And now what we're trying to do is we are actually trying to calculate the number of settlements within this buffer zone. Now when we look at this plot, I think it's quite evident that we can count the settlements one by one just manually. However, that's because this plot is quite simple compared to real life plots that can be extremely complex, and we would definitely need the assistance of a computer to do that, as it would be impossible or it would be very impractical to do the counting by ourselves. So when it comes to this line of code, what it's trying to do is it's trying to basically identify all the settlements that lie within this buffer zone and save that to a separate GeoPandas geodata frame called settlements_within_buffer. However, in order to do that, you will actually have to specify this river buffer not as a geoseries as it has been done in this particular example, but we need to specify that as a polygon type shapely geometrical object. So instead of having just the river buffer over here, I'm going to specify a river buffer dot unary union, which is basically returning a geometry containing the union of all the geometries in this geoseries, which river buffer happens to be a geoseries in this case. And if you were to check the type, the file type, what we can do is we can just simply check type over here. And now you can see that it's a shapely polygon geometrical object. So once we make that amendment, if we were to run the code, it's supposed to calculate the settlements within this buffer zone. That means each of these points that are actually within this yellow color zone into a separate GeoPandas geodata frame. So we can just check that out by simply checking the attributes table in this case. So as you can see, all of these different point objects are basically the point objects that lie within this yellow color zone. And in the next line of code, when we calculate the length, that's going to give us a numerical figure, a number, which tells us how many points are within this yellow color zone. And finally, we are just adding a print statement, which tells us the number of settlements within a 5 kilometer buffer zone in this particular example. And right over here, what we're doing is we are specifying that number, which again links back to this variable over here. So if I run this entire block of code, you can see that it basically gave me the answer as 38. So the number of points within this buffer zone in this particular case is actually 38. And you can see that if I were to change the buffer distance to be, let's say 9,000 instead of 5,000, and if I were to run the whole block of code, now you can see that my yellow color zone expanded and the number of points within a buffer zone of 9 kilometers basically increased from 38 to 46. And similarly, if I were to decrease this number to, let's say, only 1 kilometer, and if I run the block of code, now you can see that basically there are no settlements within a buffer zone of 1 kilometer from the river, as you can see from the plot as well down here. So you guys can see that even though the response that we got from ChatGPT was not 100% perfect, we just had to invest only a little bit of time to make sure that this code works in the way that we would intend for it to work and deliver the specific results that we are looking for. So that concludes example number 4, and now let's move on to example number 5. Alright guys, so in example 5, what I'm trying to show you is how ChatGPT can assist us to create a simple population density map by combining information from an Esri shapefile and a simple data table, which consists of population details. So I'm going to ask ChatGPT, when given an Esri shapefile of, let's say, districts of polygon type and a CSV file which consists of a table with 2 columns showing the names of the districts and its population, write a code snippet to read both the Esri shapefile and the CSV file and calculate and display the population density as a map using Python, GeoPandas, Pandas and Matplotlib libraries. So this is going to be my request to ChatGPT. So let's head over to ChatGPT, and since this example is not really connected to the example number 4, I'm going to create a new chat and basically enter my request over here. Alright, so this is going to be the request, and let's see what sort of response that we're going to get when I hit enter. So as we advised, it's basically using the 3 libraries that I specified right over here. And in these 2 lines, what it's doing is basically it's reading in the 2 different input files. So one of them is going to be a shapefile and the other one is going to be a CSV file. So to read the shapefile, it's using GeoPandas library, and to read the CSV file, it's using the Pandas library. And after that, it's performing a merge operation to sort of extract the population information from the population CSV file and transfer that information into the attributes table of the district's GeoPandas geodata frame. And after that, it's calculating the population density simply by dividing the population by the spatial area of each of the district's polygon objects. And I think the rest is quite self-explanatory if you had followed the example 1, 2 and 3. As we created this figure and the axis object multiple times during those examples as well. And over here, it's basically passing the arguments to do the plotting based on the density column. And right over here, you can see that it's basically assigning the type of color RAM to be used. So before I copy this code snippet into my Jupyter notebook, again, I would like to take a couple of minutes to show you the datasets that I'll be using for this example in ArcMap. So over here you see a map of Switzerland, and each of these different polygon objects basically refer to cantons, the 26 different cantons of Switzerland. So in this example, the population density map will be created based on the cantons, not really based on the districts, even though we generated the generic code using ChatGPT for a case where we have districts, but it's not going to be an issue at all because the method is going to be exactly the same. And if I were to open up the attributes table, over here you can see that I don't really have the population information in here. All we have over here is basically 3 different columns if we just ignore this FID and the shape column. So the first one is called name, and we just have the name of the country, and over here it's specifying that it's a canton, and finally we get the name of the canton in this column. And in addition to this Esri shapefile, I also have a CSV file, which is this file right over here. And in the CSV file, what you can see is we have the name again, similar to this column, and additionally we also have the population information. So basically what we're trying to do is we're trying to transfer this information into this shapefile based on this common column called name. And once we manage to get the population information into our Esri shapefile, we can use geometrical properties of each of these in order to calculate the area of each canton, and based on that we can actually derive the population density map, as we saw from the code that was generated by ChatGPT. Alright guys, so without further ado, let's jump in and get started by copying that code snippet into our Jupyter Notebook. So let's click right over here, and for this example I'm going to create a new Jupyter Notebook called example 5. And since the shapefile that I'm going to read in is going to be the cantons of Switzerland instead of districts, I'm just going to rename this to be cantons, and over here we will have to specify the path to read in that shapefile, which is going to be this shapefile right over here. So let me copy this out from here and simply paste it and specify the name of the shapefile. switzerlandcantons.shp, and that'll take care of the process of reading in the shapefile using GeoPandas library. And in addition to that, we will also need to read the CSV file, which is this file right over here, swisscantonspopulation.csv. so that's going to be right here. However, in addition to the file itself, I would have to specify the file path as well, just like this. And again, instead of districts, I'm just going to replace all the district labels by cantons. And as I explained to you guys, the merging should happen on a common column. And in this example, if I were to open back the attributes table, the field ID or the common column in this particular case is actually going to be this name column. If we quickly open up the CSV file and have a look at this column heading, you can see that it's basically the same. So right over here, we have to make sure that we perform this merge operation on name. And for the time being, I'm just going to comment out all of these lines of code because I do not want to execute them just yet. And if I run this block of code right now, everything until this point will get executed. So let's hit run and see what sort of a result we are going to get. Yeah, it seems like we're having an error message, and yes, I think over here I need to specify the file type to be .csv, and let's run this again. And after the merge operation happens, if I open up this cantons GeoPandas geodata frame, so this is how it looks. You can see that the merging has happened based on this name column. So now we have the name, its geometrical properties, as well as the population information as well. So what we can do is we can basically activate this and replace these districts with cantons. So what this is going to do is it's going to add a new column to the right side over here called density, and it's basically going to calculate the density by dividing the population value by the corresponding area value. So the area value will be actually calculated based on this geometrical information of each of the canton polygon features, as you can see from here. So let's execute that command. Yeah, and since these names are case sensitive, we need to make sure that we enter the field name correctly over here. And let's run this again and see what sort of an output we are going to get. If I were to run this cantons GeoPandas geodata frame again, now right over here you can see that it calculated the density for us. So simply by dividing this population value by the area of each of the different features. And now what I'm going to do is I'm going to activate all of these lines of code. And this one is supposed to be cantons.plot. And we are doing the plot based on this density column. Right now we can go ahead and run this command. And sure enough, we get the population density map based on the cantons. However, you can see that there are a couple of things that we can actually do to improve this map. So for example, instead of using white as the edge color, we can use black. And when it comes to choosing a color map, we can actually head over to the official documentation of Matplotlib library, and we can identify what sort of a color ramp that we think would be most appropriate when creating this kind of a population density map. So let's say if I were to go with a color ramp like jet right over here, what we can do is we can basically replace this with jet, and we can run the command and see how it looks. Or if you decide to go with a single color with a nice gradient like this, let's say something that changes from yellow to red. Yeah, so with this kind of representation, you would be able to see the cantons that are identified as the cantons with a higher population density and the cantons that are considered to be generally lower in population density. So as you can see, the canton right over here at the corner is identified to be the one with the highest population density. Alright guys, so that brings us to the end of the example number 5. And now let's move on to example number 6, which is the final example that we are going to discuss in this tutorial. Okay, so in this final example, what I'm going to do is I'm going to ask ChatGPT to list down the 10 most visited tourist attractions in South America. And in that list, I'm asking ChatGPT to include the following details. For example, the name of the tourist attraction and the country in which it's located, as well as the latitude and longitude information. And I'm asking it to format the results in a tabular form and provide the lat-long information in decimal degrees. So you can see that in this example, as opposed to me going out there and finding out this information, I'm directly asking ChatGPT to find this information for me, which is also another thing ChatGPT is really good at. And once I have this data in the form of a table, I'm going to copy and paste it basically on an Excel spreadsheet, and I'm going to create one of my own CSV files. And after that, in the second part of this final example, I'm asking ChatGPT to write a Python code snippet to import this dataset and plot the locations of the attractions as points on a base map using GeoPandas library. And I would advise ChatGPT to make use of this latitude and longitude columns to plot the data points, and also finally display the name of each tourist attraction as a label on the plot. Alright, so to get started with this, let's head over to ChatGPT first. And I'm going to enter the first part of my request right over here. Alright, so let's hit enter and see what sort of a response we're going to get. And as you can see, it nicely formatted the results in the form of a table. In the first column, we have the tourist attraction, followed by the country, latitude and longitude. And just like I mentioned, it gave me the latitude and longitude information in decimal degrees. So as I told you guys, I'm going to make use of this information to create a CSV file of my own. We can simply do that by copying this and basically pasting it on an Excel spreadsheet. So let's just right click and select copy. And I have opened up an empty Excel spreadsheet. We can go to paste and paste the data just like this. So you can see that we still have the 4 columns. And after that, to create a CSV file, all we have to do is just save this file as a CSV file by heading over to File, Save As, and just basically browse to the folder in which you would like to create this CSV file. When it comes to the file type, we'll have to create CSV over here, comma delimited. And I'm going to provide a file name called Tourist Attractions. And let's hit save. And just like that, we managed to create our CSV file. So what we can do is we can go ahead and minimize this window. And now what I'm going to do is I'm going to enter the second part of my request. And that's going to be the information pertaining to me having created this CSV file. I'm just asking ChatGPT to provide me with a code snippet to import this file and plot this data as points on a base map of South America. So let's go ahead and enter the second part of the request. And right over here, just to avoid complications, I'm asking ChatGPT to not use the basemap library. Well, when you're plotting stuff on basemap, there's actually a comprehensive library called basemap that you can make use of. However, if you haven't installed that, then it's going to take an extra step to basically configure that basemap library. But I'm trying to avoid that by asking ChatGPT to specifically not use this basemap library. So that way ChatGPT will not try to use this basemap library, and instead it'll try to make use of some of the inbuilt basemaps that we can get when we install the GeoPandas library. Alright, now let's hit enter and see what sort of a response we're going to get. And just as we requested, you can see that it generated the code snippet. Using this line of code, it's basically reading in the data table, and it has assigned a name called touristattractions.csv to the file name, which coincidentally happens to be the same file name that we assigned. And over here you can see that it's basically converting that pandas data frame into a GeoPandas geodata frame using the latitude and longitude information. And right over here, it's basically defining a basemap of South America. Now, since I was very specific about not using the basemap library, over here you can see that it didn't really try to import that basemap library, but instead what it's trying to do is it pulls inbuilt information from these GeoPandas datasets, and using that, it's basically creating a basemap of South America. Right over here, it's plotting the tourist attractions as points on this basemap. And finally, just like we requested, it's basically adding the labels to the points. Now we probably might have to do a couple of changes, especially when we are referring back to the column where we have stated the names of these tourist attractions. If I remember correctly, the column heading was tourist attractions instead of name. So we might have to change this name heading to probably tourist attractions if you're using that CSV file that we created. As you can see right over here, we do not really have a column heading called name, and we'll take care of that part when we actually get to that. So what I'm going to do is I'm going to open up a Jupyter Notebook, a new Jupyter Notebook, and let's name this as Tourist Attractions in South America. And after that, what I'm going to do is I'm just going to copy this code snippet and just paste it right over here. Just do a preliminary check to see what sort of changes we are going to require. Right over here, when reading the data file, we are no longer going to require any name changes, just because we happen to use the same name for the CSV file as I mentioned. And when it comes to the figure size of the basemap, I'm just going to stick with the default values just to see how it looks. But once I manage to get this code up and running, if I think that further changes are required, I could just go ahead and do them accordingly. And right over here, as the name of the column from which it needs to pull the data in order to create the label, just going to replace this with tourist attraction, and the same goes over here as well. And after that, what we can do is we can just simply run this and see what sort of a response we're going to get. Yeah, as you can see, without much of a hassle, we managed to basically pull the data from a CSV file and plot them on a basemap just like this. And of course, you can do the regular changes if you would like to do so. For example, if you would like to change the color of this marker to blue, you could do that as well. And at the same time, if you would like to increase the figure size, let's say instead of 12:8, if you would like to go with maybe 15:12, you could always do that. And if you rerun, you can see that the changes take place accordingly. Alright guys, so as you can see, ChatGPT can be used as a very helpful tool when performing geospatial analysis, and it can be used in a number of ways to actually increase your productivity when working with geospatial data. And it'll definitely be a tool that I will be inclined to use just because of the way it can increase my productivity when using Python to perform geospatial analysis. And one of the benefits, as I mentioned time and time again, when using ChatGPT is that we can be very specific with the requests that we make depending on the nature of the task that we're trying to accomplish. And ChatGPT is able to generate this kind of very tailored code snippets, which most likely would require some intervention from our side as well. In most cases, it won't really work out of the box, so you will have to know actually what's going on in the background. And once you manage to make those specific changes accordingly, you can get the code snippet up and running just in no time. So with that, we have reached the end of this tutorial. If you do have any questions, don't forget to add a comment down below. And if you did like this tutorial, You can show your support by hitting that like button, and if you'd like to stay tuned for this type of interesting tutorials, you can always consider subscribing to this channel as well. Thanks a lot for sticking with us, guys. I'll see you again with another tutorial very soon.